Hey everybody, thanks for coming to this presentation, deep dive on Amazon Managed Blockchain. My name is Jonathan Fritz. I run the Amazon Managed Blockchain team. Really excited to have you here and talk about some of the things the team has been doing in the new service that we shipped earlier this week in Andy's keynote. So, agenda, what we'll go through. First, I want to talk about really how AWS defines what blockchain technology is. If you go walk down the street, you talk to 10 people and ask, what does blockchain technology do? What is it? People might say it's Bitcoin or cryptocurrency. Other folks might say it's really more of a ledger. And what we really want to do is take a minute to kind of describe how AWS, what we think blockchain technology is, and the difference between centralized technology, decentralization, and thinking about really when you might want to use a blockchain and the elements of when we say blockchain technology. What are those attributes of what makes something a blockchain technology? Next, we're going to go talk a little bit about the service we just launched, Amazon Managed Blockchain. We'll walk a little bit through how it works, some of the different features, the pricing, and then take a little bit of a deep dive into Hyperledger Fabric, which is the framework we currently support right now in the preview. And then finally, we'll end with a demo of Amazon Managed Blockchain. I'll walk you guys through the console, and then at the end, we'll have some time for questions. So, what is a blockchain? And I think it's really worth starting out at this point because there's a lot of what we found when talking to customers is some confusion around blockchain technologies versus ledger technologies, and then thinking about when you might want to use a decentralized technology versus something else. And I think really to start out the story actually is talking about ledgers. And for those of you who saw Andy's keynote earlier this week, we launched two services, Amazon Managed Blockchain and Amazon QLDB. And QLDB is our managed ledger service. It stores an immutable history of all the data that you put in, and it's cryptographically immutable, and then you can verify it using a digest that you can retrieve from the service. And so, as kind of Andy pointed out in his presentation, this use case is really great for when you can use a central authority and you need to verify information that you're putting in. So what customers do today in this case is they use a database, and then you might have audit logs, and you have to secure those audit logs, and then find a way to kind of query the audit logs to see what the previous state of all of these things were. Now, the nice thing about a ledger, and we'll talk a little bit more about ledgers in a minute, but it kind of is one tool that you can query the global state of what is the current state of everything, but then go back in time and visualize and kind of have the cryptographically secure history of every state change that got you to that point. So that is a release today, and it's really great for use cases where you want a verifiable data set against maybe internal tampering, or you can even expose that ledger database to other parties. So it's not necessarily a database just for you, but you can also do that with MySQL with an abstraction layer with access control on top where multiple parties are interacting with the database that you own. And so we found that many customers, when they're thinking about use case in this space, some of them end up here, that's what they want to use, and QLDB would be the right tool. But what we found was that not every use case really falls under an area where you can have a centralized database, or in this case, a centralized ledger database. And when we're talking with customers, there's a couple of different themes that we found, and I want to go through a couple of them on this slide that kind of starts maybe thinking, well, this isn't really a centralized use case. This is a use case that requires decentralization. So I'll walk through a couple of the things on this slide to kind of give you an idea of some of these themes. So first, many business networks today have things where I want to transact with somebody else directly on the network, but I actually don't directly transact with them. Instead, what I do is there's a central authority that we all trust in the network, and I transact through that central authority to, in the end, transact with you. But that central authority, it's expensive, right? They take a cut of that transaction. It's not as efficient. Oftentimes, it takes days for that central authority to then clear it and to have, say, that transaction get to you. So expensive, not as efficient, and then I still have to audit you to make sure, and audit the central authority to make sure what I thought happened the way that it did. So inefficient, expensive, and requires auditing. And so that case, you're saying, well, if I really want to transact directly with you, that's really more of a decentralized use case when you want to remove the central authority. Another example, which I think this one's particularly interesting, is a consortium of companies might be able to get to a better outcome if they could, say, share information and have like an immutable data set that every person in that group or every organization in that group could independently verify. But problem there is, who owns the database? I might say, yeah, John's company will own the database, and I'll grant access to everybody, and then you kind of load the data set with me. The problem there is that everyone might not agree that I should own it. Maybe everybody wants to own it, or maybe no one wants to own it. We maybe could create a joint venture, and we each have a stake in that joint venture, and that joint venture owns the database. But obviously, this is all starting to get really complicated, and in the end, probably won't really move forward. And that's sad because, in the end, if everyone could have one of these data sets where everyone kind of has equal ownership in it, in that consortium, that group would get to a better place. Almost kind of like a coordination problem. And as you see in some of these other examples as well, this idea of groups, transparency, trust, and transacting is key, but there aren't really, you can't really use a database to do that because, does everybody own the database? And really calls for decentralization because everybody needs to have kind of an equal part in whatever the solution is versus a centralized system. And so it's these themes that really define how we think about blockchain, which is it builds trust in a network. It eliminates the need for a central authority, and it takes kind of the example on the left where it's like a hub and spoke with a central authority into something on the right where you have everybody directly interacting with each other in a verifiable manner, in a transparent manner, and every customer has basically their own data set. They don't need to rely on anybody else in the network, and everyone is kind of democratized, so to speak. So that's kind of when you say, well, ledger database can't do that. A regular database can't do that. And it really calls for a decentralized blockchain technology. But when we talk about blockchain technology, it's really not just the ledger. That sometimes people would say, oh, blockchain, it's a distributed ledger. We tend to think that a blockchain, kind of like an ERP system, has a database in it. A blockchain has a ledger, and we'll actually talk about that in a minute, but it's got actually three parts. We think it's kind of like a layer cake of the technology stack. At the bottom is a ledger. On top of that is a consensus mechanism, so the network decides what to write to that immutable ledger. And at the very top is a smart contract application execution engine. And it's those three parts together that really consist of a blockchain technology when we talk about blockchain. So let's start. So first, this is kind of where blockchain gets its name. The first kind of technology layer we'll dive into is the ledger database. But the blockchain is a ledger database, but kind of one of the differences between something like QLDB and blockchain is QLDB is a ledger database that is owned by one entity, a central authority. Blockchain, everybody in the network has a copy of this ledger database. So if me and two other people are in one of these permission networks, each of us has a full cryptographically secure ledger that we each own. So if somebody leaves, say, the network, it's not like they leave with all of the data. I still have my copy. The ledger has some interesting properties. In this case, the ledger database has two components we'll talk about in the next slide, but the journal piece of a ledger database is the blockchain, which is basically the cryptographically secure transaction log where it uses a hash basically from the previous block to make sure that there hasn't been any tampering. If you did tamper with, say, some transaction that happened a while ago, you could look at all the hashes and figure out, hey, wait a minute, something doesn't add up here. And so this is kind of a good representation of what the journal in the blockchain ledger looks like. And then you can go query it to see, what was the state at this and how did it evolve over time. And then using these cryptographic methods, you have faith that that is what it should be. But kind of taking a step back of kind of what is the ledger database in a blockchain, and the same thing, same idea of what is the ledger database that is QLDB. It's really two components. It's that journal that is the chain of blocks that's cryptographically secure, but then also you probably want to query what the current state of the network is. And kind of taking a banking example, I might have $100 in my account, and that's the global state. And for most intensive purposes, that's what I'm interacting with to know, hey, how much money do I have in my account? But the journal would show every single transaction that got me to 100, all the debits and credits, say, in this example. And so you need both in a ledger database. And in, obviously QLDB is a great way for in a centralized use case to access all of that. In blockchain, every framework basically has a version of this as well, where you can go back in time and see what happens, and query and get the global state. So on top of that ledger database, which remember everybody in the blockchain network owns their own copy and can independently verify their own copy of that data, is the consensus mechanism to help the network figure out, are things, what gets executed and what transactions are okay to add into the ledger. And there's a ton of different ways this gets done today, and it depends a lot on, kind of some of the attributes of the network, and a lot of times the level of trust between parties in the network. And so on one extreme is a public network that has to guard against this idea of Byzantine fault tolerance, which is an interesting kind of paradox type thing, the Byzantine generals problem, where basically the short of it is, if you're getting information from a bunch of people that you don't necessarily even know who they are, how do you figure out what is kind of the correct answer, what is correct and what is in fact malicious activity? And something like, say, the Bitcoin or the Ethereum networks, which are public, I could download the open source software, join the network, and start trying to send possible transactions to include into those blockchains, and maybe send nefarious things, or you don't really know. And so the consensus algorithms on those networks are guarding against this specific problem. And for Bitcoin, an example is proof of work to solve this really complex mathematical problem, with the idea that a nefarious actor wouldn't be able to solve that every single time, because it just takes a lot of compute power and time, and sort of like kind of run away with adding all these bad transactions to the network. So that's one way to do it. Doesn't work if you own over 51% of the network, though, but that's another story. So the problem there, though, is that because it takes all this compute power to come up with this mechanism, it's expensive, so it uses up a lot of power. And also, it's relatively slow. Like the Bitcoin network, I think, does between 5 and 15 transactions per second, which in some use cases is totally fine. But if you have something like Visa, which does hundreds of thousands of transactions per second, that mechanism is too slow. That's kind of on one side. On the other side are permission networks, where you might not necessarily trust everything everybody does in the network, but the network is locked down. You don't have to worry about some random node coming in and kind of being nefarious. And so you have some level of trust and security, and you're able to then switch the consensus mechanism to something that's not quite as heavy to then kind of validate that transactions are okay. And we'll talk a little bit more about private and public networks in a minute. But in that case, you can do thousands of transactions per second, and a couple orders of magnitude faster than what the public networks can do, because you're not doing all that math, complex math, to basically prove that the transaction should be added or not. There's a ton of interesting work still being done. This is still day one for a lot of these mechanisms. A lot of interesting maths being done to try and figure out new approaches to be able to do this. Also hardware accelerations, a variety of other interesting ideas that are being done to try and boost the performance of this in both the kind of public nature of things and in permissioned networks as well. So we talked about kind of the base ledger that everyone has a copy of, the consensus mechanism where the network decides what updates basically to add to the ledger, and then at the top is the smart contract layer. And so a lot of people, when they think about blockchain, they think of just adding and subtracting value. But in reality, blockchain is a decentralized application environment where you can deploy applications that do all sorts of stuff that run in a decentralized fashion across the network. Each framework has its own way of doing this stuff. Different languages, different kind of programming interface, and different functionality that's included. And so there's a variety of different ways these frameworks go about doing it. Also, these smart contracts can interact with things off of the blockchain, and there's some interesting ideas around maybe storing the hash of an object on the blockchain instead of an actual object or file. And so if you retrieve it, you can verify that it's actually what you thought it was using the hash, but that actual object isn't there. And so when thinking about exactly what's being stored in this immutable fashion and what isn't, there's a lot of interesting architecture being done to try and figure out the best way to do some of this stuff. Public and permission networks. So there's kind of two different types. Public network obviously is public. Anyone can join. And there's this concept of cryptocurrency to incentivize people in the network to continue running these algorithms to try to add the right transactions to the ledger. And so that's kind of an inherent cryptocurrency. When you hear mining, that's what's going on, is people are trying to, in Bitcoin example, find that number that needs to be calculated and then send that block with that number out, and they get a reward for being the one who basically won the mining. So that's one world, and anyone can join, and there's kind of inherent cryptocurrency. On the other hand, there are permission networks that are not public, that you have a known group of people in that network. And there isn't really a cryptocurrency because the idea of what you're trying to do is some business externality that's good. So you're not really in there to get the cryptocurrency reward. You're in it because maybe a consortium of banks can more efficiently do asset transfers, or something like your supply chain can be 15% more efficient, and that's where the benefit comes. So lots of interesting use cases for both, and they kind of divide themselves in those two areas. So, as many of you know, customers are experimenting all over the place with this technology. I really like the slide. It shows all the different industries where you have, established enterprises and small startups trying to think about how can we innovate and use this technology that enables decentralization in a secure, trusted way to build interesting things and make experiences better for their customers. And kind of just taking a look through this, and there's kind of good examples for all, but the idea of patient records, would there be a more efficient way to exchange patient data between hospitals to make sure that certain information isn't lost, or that certain things are updated, or even the identity of a patient can be tracked more efficiently. Ideas around obviously things that involve asset transfer, so putting your deed of a house on a blockchain so you don't need an escrow, selling your car on the blockchain, other types of assets, or even buying something where a bunch of people can, kind of almost like crowdfunding, chip in and buy something and then have that ownership represented on a blockchain network. Kind of in energy, there's ideas of prosumers who want to put energy back into the grid, using smart contracts to be able to automate getting paid for energy you might put back. Digital identity to make it easier to track applicants who want, say, to get a loan and their credit score across a variety of different organizations in that value chain. Gaming and advertising, a way to automate royalty payments and add click-through payments and things like that. There's a variety of different things all across the board. Some will stick, some won't. But the idea that this is a fundamental shift in what you can do in kind of these decentralized networks, and adding this trust component in there and verification in there. And so there's a lot of interesting applications for that. We're focused on two that we're particularly excited about. One is supply chain. I mentioned this a little bit earlier, where obviously there are supply chains today. So somebody earlier asked in another session, do you need a block? Why do you need a blockchain in a supply chain? The answer is, in some cases you might, but in many you probably don't. I mean, there's many supply chains today that use MySQL. QLDB will be useful for supply chains that don't really need decentralization. That you have one company with a centralized database. It's really good at tracking the state of that asset from the start, all the way to the end. And anybody else who might want to interact with it will interact with that one company who has that database. So I might expose access to you, but I own it. In a decentralized case, though, everybody in the supply chain essentially has their own database, their own node. But the difference is that instead of having to move data back and forth between silos, or me having to go interact with you every time, I've got my own verifiable copy. I can see exactly what's going on. I don't need to call you. I don't need to access your database if it goes down. I've got my own copy. I'm in charge of my own destiny. And I might use that to also interact with other people who if you think about the network, not everybody necessarily needs to interact with everybody else. And so there's some efficiencies that you can get by tracking an asset across a variety of different silos, because blockchain eliminates the silo. It's one kind of global state of the network that you can trust. So like in its state of a recall, I don't need to go through and try and figure out exactly with each person or each organization, how is this represented as it passed through in that supply chain. I have one view of everything throughout the whole thing across every organization that's participating. So when thinking about if you're going to redesign supply chain software like Supply Chain 2.0, this sort of thing could make supply chains much more efficient and robust in the case of recalls and things like that. I like this slide too. There's a ton of interesting financial use cases, and not really referring to say cryptocurrency here, but more consortiums of known financial institutions. And there's some great ones on this slide, like the idea of obviously making asset transfers between banks seamless, easy, and more verifiable and faster, but also finding the identity of your customers in your, say, financial institution, and having when they show up maybe with someone else, being able to easily track that person across and kind of have their, say, credit score and other attributes verifiable by other institutions, so you don't need to do the same check every single time. There's a variety of other things here as well. And we're seeing a ton, and working with financial institutions to figure out what are ways that decentralization could help make your business practices more efficient and in turn get a better experience for their customers. So a lot of innovation. We talked about things ranging from supply chain, financial services, royalties from music streaming, all these different interesting use cases where blockchain can really make a difference. But it's hard to use. And if you're kind of building a permissioned blockchain network using something like Fabric, it's even harder because you have to deal with provisioning hardware. You've got to set up all this software. You need certificates in the sense of a permission network, and so you've got to get an HSM. You got to configure access control. There's some other interesting distributed systems components that are required for some of these systems, like Apache Kafka for something like Fabric. Adding and removing members, if it's permissioned, you've got to deal with certain networking things. So a bunch of kind of muck to get through to get these things set up. And when the goal here is fast experimentation, getting some of these things into POCs and into production, spending 3 months and having to pay for expensive consultants and kind of or software license, that sort of stuff, to get this up and running is kind of a non-starter. And that was actually some of the feedback that we were getting from customers earlier this year when we really started diving into more of these use cases. And that was some of the impetus behind releasing our blockchain templates in April. The goal was to really make it easy for people to get up and running quickly using certain open source frameworks. But what we found was also that customers really wanted kind of a more robust solution, and a solution where they could start implementing these things and then get into production in kind of the same sort of service, and also have more features around the things that you can do. We also found that customers really, and we do too, believe in the open source technologies for doing this stuff. I mean, we see these networks spanning all over the place outside of any one cloud, these kind of large blockchain networks, and having an open protocol is super important, kind of like the internet. If we had a proprietary protocol or something like that, it'd be more difficult to kind of get this mass adoption. So we've thought about it, and talking to customers and some of the use cases, Hyperledger Fabric and Ethereum were the two ones that we want to focus on first. And from customers, they like the idea of private permission networks and the features that Fabric have, and we'll talk more about that. And then for Ethereum, some use cases interacting with the public Ethereum network, but also using Ethereum in a permissioned scenario as well. But the idea is these kind of open frameworks, easy to get started, and easy to kind of build these networks because it's an open protocol. And so blockchain templates, we've got more feedback, and we're super excited to have announced earlier this week in Andy's keynote the Amazon Managed Blockchain. And the idea here is that we really want to make it easy for customers to get started, kind of prove out their use cases, learn how to use these technologies, and then work with customers, getting them into a production scale. So what is Amazon Managed Blockchain? Amazon Managed Blockchain, a fully managed service, makes it easy to create and manage scalable blockchain networks using the open source frameworks Hyperledger Fabric and Ethereum, and it's in preview right now. We currently have Hyperledger Fabric available in the preview, and Ethereum is coming soon. So a couple of features that I want to highlight about Amazon Managed Blockchain. First, it's really fully managed. It's super easy to get a network up and running in 10 to 15 minutes. And for things like Hyperledger Fabric, there's a lot of complexity in building and managing this stuff if you were going to do it by yourself. With Amazon Managed Blockchain, a couple of clicks, you're able to get the network up and running, and then a couple of clicks, you can invite other different AWS accounts to come join. They get the invitation, and then they create their memberships, their nodes, and all of a sudden you have a kind of blockchain network scaling out where you can transact with other parties. We support 2 open source frameworks. Hyperledger Fabric is available today in the preview, and then Ethereum is coming soon. And they're useful for a couple different use cases, and we'll talk about that in a minute. This one's interesting. We built the service to truly be decentralized, and it's important because in the case of say S3, I can create an S3 bucket. I can give access to all of you, and everybody can access that data in there. But if I shut down my AWS account, that S3 bucket is gone. That's kind of antithetical to a blockchain network where if one person leaves, or if there's an owner of the network, that person has more power than everybody else. They leave the network and it shuts down. People might be a little bit wary of joining it because the power balance is off. And so with Amazon Managed Blockchain, it is decentralized. No one owns the network. If I create a network and invite some of you and then I leave, that network is totally fine and running. I'm not able to access it anymore because I'm gone, but all of you can still join. And so the idea that it really is decentralized and allows people to have an equal seat at the table when they're in a consortium. We're including, it's not available yet in the preview, but it will be available soon, a voting API where members in the network can vote on who to invite, who to maybe kick out, but also what the rules of voting are, that this is configurable. It could be that in some cases, the person who creates the network is using it in a certain way where if they leave, they want the network to be terminated. Maybe if in a supply chain, I'm the main person in that chain and want to make sure that that chain doesn't exist without me in it. But also, there's certain majority rules, other types of voting mechanisms that we want to put in to make sure that they're configurable and that the network can democratically govern itself. Amazon Managed Blockchain, reliable and scalable. That we've backed, there's a component called the ordering service in Hyperledger Fabric, a very important component that usually uses something like Apache Kafka and with open source. And Kafka is great, but it's not really designed to do what the ordering service needs to do, versus we back our ordering service with Amazon QL, the same technology that backs Amazon QLDB, with the goal of really building a bulletproof, durable, and available historical transaction log that is the component that backs the Hyperledger Fabric orderer. And so we back with QLDB technology. We also actually back the Hyperledger Fabric CA with AWS Key Management Service keys. And so that root CA is encrypted using KMS grade, enterprise grade technology as well, versus open source. You need to go buy your own HSM or secure your keys, your certificate some different way. Amazon Managed Blockchain, low cost. You only pay for what you use. We'll talk a little bit about the pricing dimensions and rates later on in the presentation. And then finally, it's integrated. And this is actually a use case that when talking to customers earlier in the year, we found that people were pretty excited about wanting to analyze the information that's going on in the blockchain off the blockchain, because you can get it, different analytics tools, and also not put pressure on the system that's actively running transactions as well. And so this is coming soon. You can send network activity data from your managed blockchain network to a QLDB database you own, or ledger database that you own, and it's that information is cryptographically secure in there, and also you can use some of the analytics functions QLDB has to query it. So a quick look at Hyperledger Fabric, one of the frameworks we support. Hyperledger Fabric is all about permission networks, and that's also how it gets a little bit better throughput. I think there's some public notes around it getting around 2,000 TPS that are available in some studies that have been done. But also, because it's private, they have a semblance of access control. They've got a couple of features to make it so that not everybody in the network sees everything that happens. We'll talk a little bit about channels later, but it has a mechanism where I can create a channel and have maybe members A, B, and C transact on this channel, and D, E, F transact on another channel, and so on and so forth. There's also some other features that are more fine-grained around access control, who can access it, who can see bits of information on each channel. Hyperledger Fabric has smart contracts called chain code, written in Go and some other languages. I think Java is supported, and Node.js as well. They're executed in Docker containers on the peer nodes. It has a concept of validation where if I propose a transaction, the rules on that might be that 3 out of 5 separate organizations in my network need to validate that that's true. We'll talk a little bit more about the transaction flow for Hyperledger Fabric later in the presentation. But the idea of members validating transactions to decide whether they're okay to run or not. And finally, Fabric has no native cryptocurrency. That these are private networks, and the idea of maintaining the network is because you're getting some business externality out of it. And Fabric is available today in the preview. Aetherium, which is coming soon, is another very popular blockchain framework. You'll be able to connect to the public network or create a private network amongst a set of known participants. Ethereum is super scalable. The public network has thousands of nodes. It doesn't really have the same concept of members the way Hyperledger Fabric does, although in a permission context, you can add in this idea of members and organizations reflected on a private Ethereum network. Variety of different consensus algorithms that you can use depending on do you know your participants or not. And the access control features are not quite as robust as they are for Fabric. There are some ways of using zero-knowledge proofs and other things to try to lock down who can see what. And there's a lot of innovation going on in this area on how to lock things down. There's also some other kind of pending JIRAs and stuff out there on adding this stuff to the project. But Fabric was kind of built originally with this more in mind. So really creating a network with Amazon Managed Blockchain, super simple. You go to the console or use the CLI or the API, the AWS SDK, and you, in a couple clicks, create a network. When you create a network, you also create your membership on that network. You can't have really an empty network with nobody in it. And actually, there is no delete network API. The network is terminated when the last member leaves. So create a network with my member, then I invite other people to join, other AWS accounts, or I could actually create members in my own AWS account if I want to, say, create a test network to simulate multiple parties transacting. When I create my membership, then I create some peer nodes as well. Everybody else will create their peer nodes, and then I deploy chain code in the case of if I'm running a Fabric network, and query the ledger and start transacting. Here's more of a view of exactly like what's being provisioned, and I'm going to take a minute to walk through to really try to hammer home exactly how the service is built and how to interact with it. And so this is an example of a managed blockchain network with Hyperledger Fabric with 3 different members. And I guess kind of walking through the flow that I talked about before, let's imagine that member B and C haven't been invited. So you just have member A creates the network. So when member A creates the initial creator of the network, remember member A doesn't own it, but somebody needs to be the initial creator. Amazon Managed Blockchain creates kind of all the shared components and networking components that's needed. It provisions a Hyperledger Fabric ordering service, an available version of that backed with Amazon QLDB technology. It creates an AWS private link endpoint, basically, for you to then create your VPC endpoints. And then for your member, it'll create your Fabric CA with kind of your chain of trust and that certificate, the root CA, which basically identifies your membership on the network when there's many members there, and a couple of other components. And on all these, you'll see in the console, we expose all of these via an endpoint on that component through that private link endpoint that's there. And so member A is created. If I wanted to, say, interact with my Fabric CA, and then there's an API call, create node to create my peer nodes, the first thing I need to do is create a VPC endpoint with the VPC endpoint service name that Managed Blockchain provides for that network. And so as member A, as you can kind of see over there, account A, I create a VPC in account A. I create a VPC endpoint that maps to the VPC service name, endpoint service name for my network, and then any EC2 instance I have in that VPC that I own can communicate with the endpoints of basically the order endpoint, the ordering service endpoint, my CA endpoint, and all of the peers as well. And we'll talk about why that's important in a minute. But it's kind of secure networking. We're not exposing anything to the internet. It's all exposed through VPC, and that's how you can bridge it. So if you have a VPN into your VPC or Direct Connect, you can have things outside of the AWS Fabric communicate through that endpoint and then hit the different services exposed in Managed Blockchain. So imagine member B and C, remember, aren't there. As member A, I want to invite member B and C, so I invite their accounts. They see that in their invited networks list that this network shows up, and they each create a membership and create their nodes in the same way. And then they now have access to also create a VPC endpoint with that for the VPC service endpoint that we expose. So you're not able to really do that unless you're part of the network, and we make sure that if you're not part of the network, you can't create a VPC endpoint to basically access those resources. So member B and member C, once again, in each of their respective accounts, can create a VPC that they own and run EC2 instances in there that act as clients to the network. And we say client, I really mean that you download the Hyperledger Fabric SDK or CLI, you install it on an EC2 machine, say that I own, that I'm running in my VPC, and then configure that client to interact with the endpoints exposed by Managed Blockchain for the respective resources. And that's it. Then I can start installing chain code, invoking it, registering, enrolling users, adding more users, that sort of thing. and we're running the open source bits. We're committed to working with these open source projects, and we haven't changed the APIs. We didn't make like Amazon Hyperledger Fabric or Amazon Ethereum. That we're kind of taking a similar model as we did to Amazon EMR, which is our Hadoop and Spark-based service, where we really want to kind of have open source parity with these projects. So who owns the network? We kind of went over this a little bit. Nobody owns the network. Networks are decentralized and remain active even if the initial person who created it leaves. Now, in the preview, it's not quite the case. That actually, the preview, the person who creates the network, that membership can invite other people and is the only one who can do that. But if that member leaves, the network's still active. It's just no one can really invite anybody else. However, soon we'll have our voting API where configuring voting rules, different members can vote and decide who to add and maybe who to make leave the network, and also vote on other network-wide settings. Each member pays for their own resources. We'll talk about that in a minute. And then Amazon Managed Blockchain manages shared components, like in the Fabric case, the ordering service and some of the shared networking settings, like that Vpc endpoint service that we expose. So pricing dimensions. The goal with the pricing is really pay as you go, and we don't want customers of Managed Blockchain to pay for things that they don't need and aren't using. There's a couple of different pricing dimensions. I'll go through them quickly. One is the membership fee. When you join a network, you basically have a member. You can have multiple members in a network, like say a two-member test network. Membership fee is per second and at a minute minimum. In your membership, you can create your peer nodes that kind of represent your membership on the network, and those are also paying per second, and the rate varies by the instance type that the blockchain instance class that you're using. Also, each node has some storage. You pay per gigabyte a month for that. And the final real dimension is the data that you write to the network. So everybody might be in a network, but might be actually writing different amounts of data to it. This is in the Hyperledger. These are prices related to Hyperledger Fabric on Managed Blockchain. You pay, I think, 10 cents per gigabyte written, and we track how much your membership is writing to the network. Also, I guess kind of the standard AWS data transfer rates apply if you pull data out of the service and put it into EC2 or back out to the internet. When you create a VPC endpoint, remember we talked about the way to interact with your blockchain components is through a VPC endpoint that you create. That is kind of billed separately. You create that in your account, and it's billed separately from Managed Blockchain. And you can create multiple VPC endpoints for your network as well if you're trying to access it from different VPCs. So a final note on pricing before getting into a little bit more about Hyperledger Fabric is our starter and standard edition. Like right now in the preview, we kind of have a preview edition, but once the service is generally available, we'll have two editions. The starter edition, the real aim is for test and small production networks. This is enterprise grade still. It's not like you're not getting, AWS KMS is not securing the keys or the certificates in starter edition. You have all kind of the features that would be relevant for what you would expect in a production network. Just the difference is you only can have up to 5 members in a network, only 2 peer nodes per member, less selection of instance types and maximum storage size, and the ordering service has less throughput and less availability. But however, for some production use cases, this might be totally fine. But the goal is also we really want to make a really great environment to also test POC and then also still run tests, because we found that on the network with multiple people, you might want a smaller version of that to test chain code and new applications before putting it onto a network that's the actual network of the consortium. Standard edition is built for really highly scalable production networks. You can have up to 30 members in a network, 10 peer nodes per member, variety of different instance types, T3, M5, and C5, much more storage per node, and an ordering service that can support higher throughput and higher availability as well. And for each of these nodes also you can create in different AZs, EC2 availability zones, to make sure that your applications have high availability. Okay, so switching gears, let's talk a little bit about Hyperledger Fabric. So we talked about kind of Amazon Managed Blockchain, some of the features, what it does, and how it provisions the network, but it's important to dive deep into the actual framework that's running, because when thinking about writing application code and how things work, at the core, if you select Hyperledger Fabric and Managed Blockchain, that's how things work. We didn't change the way Hyperledger Fabric really fundamentally works, and these concepts are important when thinking about how to use it and how to write applications for your network. So I really want to take a minute here and kind of walk through the transaction flow for Hyperledger Fabric. So I think that kind of adds some context into when I propose a transaction, what's going on, and how does that touch the different parts of the network that are provisioned by managed blockchain. So first, the submitting client is an open source Hyperledger Fabric CLI or SDK. And remember, that's running in a VPC in your account that you own on an EC2 instance that maybe you created, or if you have direct connect into that VPC somewhere else. And so that client, when you propose a transaction, the first thing it does is it submits it to a certain number of peers on the network. And this is where that endorsement policy comes in, because I might say it needs 3 out of 5 members on the network to be able to endorse this transaction before it can be submitted. So remember, you have to create that VPC endpoint, because that's how the endpoints and all of the peer nodes, and not just the peer nodes that you own, but the peer nodes that everybody owns. Because remember, you need endorsements from members that aren't you. So that's exposed through this endpoint. So the client interacts with the peers, sends the transaction request to each peer on the network, and then once the peers receive it, this is step 2, each peer simulates the transaction, decides whether it can be valid or not. If it's valid, the peer then sends back a note to the client saying, yeah, we endorse this transaction. Remember, the transit that's happening here is your client application and running in your VPC directly to the peers and back. And so some of this networking stuff is actually pretty interesting in how we stood it up. And the key is it's important to expose all those endpoints to everybody, because you need the endorsements from multiple members. All right, so great. So you got enough endorsements. So your client says, great, I'm going to submit it now. This transaction's OK. And the next thing your client has to interact with is the ordering service. And when you configure the client, you take the ordering service endpoint from that we provide, and then you configure the client to know where to send that endorsed transaction. So it gets sent to the ordering service. The ordering service gets the transactions, batches them up into blocks, and then distributes the blocks back out to every single peer with your transaction in it. Once a peer gets it, it actually then does another thing to see if it's still valid, because the peer has a concept of valid transactions and invalid transactions. It's possible in that whole flow of getting endorsed, somebody who validated it, if you think about just kind of the timeline, that proposed transaction might not be able to be real anymore. So the peer does kind of one last check to say, hey, is this something that should be committed or not? And if it could be committed, it is. The ledger's updated, the global state is updated, and that information is passed through. And at a high level, that's what's going on for every transaction. So if you're doing thousands of these a second, there's lots of communication from these clients getting endorsed, orders, services constantly getting new transactions, putting them into blocks, and then shipping them back out. But at a high level, this is what's going on in the transaction flow for Fabric. As I mentioned before, we've augmented Hyperledger Fabric a little bit. The ordering service, instead of using Kafka, we're using the same technology that backs QLDB, make it a little bit more reliable and durable. And the Fabric CA, we don't use kind of the open source way of securing it, which is basically just not really securing the root cert, but we encrypt it using AWS KMS technology, which is enterprise grade stuff backing our Fabric CA when you're running it with us. Chain code basics. Once again, chain code is smart application code. Fabric supports 3 languages: Go, Node.js, and Java. Executed in a Docker container within the nodes, and first you initialize it, and then you invoke the chain code when you're doing transactions. Peer nodes are kind of the workhorse of the Fabric network. That every member, you create 1 or more peers, and that peer is the thing that stores the ledger. Remember, everybody in the network is storing a copy of the ledger. Each peer has a full copy. And you install your chain code on a peer, you invoke the invoked chain code on a peer, and also the peers endorse other transactions that are created on the network as well. So once again, really the workhorse. With Fabric, we manage the peers, although you could create a peer in your own VPC that you own, and actually configure it to be part of the network as well. That peer won't be able to endorse any transactions because of the networking, that it can't reach every other peer in the network, but it'll be able to get the kind of the ledger broadcast from the orderer as well, and be a part in it. So if it's an important use case for you to have a peer that you manage, that is possible in that context with managed blockchain. Remember, peer stores a copy of the ledger, endorses transactions, and then does this final validation as well to decide, all right, well, I got this new block with transactions. Is it valid or not? Hyperledger Fabric utilizes channels for access control, and I think this is kind of a great diagram of what a channel is. different organizations, it's kind of like a isolated area of the network that you have. So maybe members A, B, and C. And when I say, might be using members and organizations interchangeably. A member in the network for managed blockchain is kind of an AWS concept. There's like a member ID, it's like a resource. And then when we configure an organization, which is a term in Hyperledger Fabric, with information from that member. So like for instance, the organization name, if you look in your Fabric configuration, is the same as your membership name. And your member ID is, we configure your MSP ID in Fabric to be that. So if I didn't mention that before, I wanted to make sure I mention it now. So anyway, so the channels of access control, you're able to have some people on some channels, some on other, and there's a couple of other access control features as well that Fabric can use. When you create a channel, you use a configuration transaction, and then kind of update transactions as well. And that's kind of when you query the ledger, there's kind of other, almost like invoking chain code, that's system chain code, which allows you to do certain operations that kind of help manage the network or change configuration around. Finally, endorsement policies. So endorsement policy, super important and configurable to decide, what is the nature of who needs to endorse and transaction before it's applied. And it's probably some number of organizations, and depending on your use case, you can configure what that is. And then endorsed transactions are the ones that go to the order. Remember, your client is getting the endorsements directly from all the different peers, and so when thinking about what your endorsement level is, that's kind of also related to what is the hardware class of your instance. That if everyone's doing a ton of endorsements on the network, you're probably going to need more CPU and more RAM on on your pure instances to be able to handle that throughput. Okay, so let's take a quick minute and go through a demo. I would love to show off the console and walk you through some of the concepts that we talked about creating networks and kind of visualizing the different things that we expose from the service. So let me quickly switch over to our console. Okay, so this is the managed blockchain console. It looks like we're still logged in. Let me zoom in real quick so we can see it. So great, so this is the first run page. So, and I've mentioned this maybe a couple times, I'll mention it again. We're in preview and would love for you to join it. Sign up, and then once we add your account, you'll have access to the console and our APIs and other things as well. But if you go into the console the first time, you see this page, and the first thing you would do is create a network. And it's super simple, as I said, in a couple clicks you can create one of these things, one of these networks. You really don't have many things to choose. One is what framework do you want to use. Ethereum's coming soon, so choose Fabric, and then your network name. So I might want to call this test network, and then I can optionally have a description, this is a test, and then hit next. And that's really all the network configuration that we need for right now. Managed blockchain takes care of setting up all the other shared resources and kind of all the other things in the background that you might need to do to create one of these permission networks. But remember, when you create a network, you also have to create your first membership as well, the kind of initial creator. And so we'll do that right now. So for member configuration, I got to pick a name. So we're just going to call this member Fritz Corp. And description, Fritz Corporation. And then the next thing I got to configure is the admin user for my network. And this is kind of the concept where each member has an admin, and that user can then go and create more users in the Fabric CA. Also, admin users can install and invoke chain code and other things like that. So you need to start out with one to bootstrap other ones. And so in this case, we add that information. So we can say John Fritz is the admin, give a password, and then the first time that I enroll, I configure my Hyperledger Fabric client to the CA client. When I enroll, I use this username and password, and then I enroll and get the admin certificate, the certificate related to that user, and then I can do other things with that and identify myself on the network. So then you would hit next. I'm not going to because I've already reached the service limit right now for my preview account. But then you hit next and then hit create, because next is kind of a summary of what you have, and then in 15 minutes or so, the network is live. And then what you would end up getting is something like this. So we're going to go to the list networks page, and let's say in this case I created this test network. So I can click on it and go to the network details page. And here, this is everybody who's part of the network. When they click on that, will see this same page. I mean, the only difference here is that the owner of the network, or the owner of a given member, will change depending on who's looking at it. As you can see here, we expose the ordering service endpoint here. Remember, you've got to create your VPC endpoint first to be able to interact with that endpoint, but here's the ordering service endpoint. And when you create your VPC, here's the VPC endpoint service name, and you use that when creating it. However, in the console, we also have an ease of use feature where you can click this, and then using the user credentials that you're logged in with, we'll go call on your behalf the create VPC endpoint API. And so it's a little bit easier to use this if you have the right permissions. And so you need to do that before interacting with these services. As you can see here, here's the member that I created with the name, the member ID, and the state. And I own it. You'll actually see a network, I'll show you in a minute, where there's other members that I don't own, and you'll see that change. If I want to invite other accounts, I can add in their AWS account ID. And then when I hit send, assuming that they're also part of the preview, they'll in their invitations panel, which I'll show in a minute, they'll see this network show up. All right, so let's click on this. So if we click on a member, we get to see a little bit more about it. The first thing is we can see here that there's, let me refresh here. Whoop. That's why you never do this live. There we go. Sorry about that. So in this case, we're looking at the Fritz Corp member, the member ID. This is the Fabric CA endpoint. So if I want to go enroll with that user, remember the admin user I create, I go to the Fabric endpoint and get back the certificate for that user, and then I can do other things like create more users. Here's the peer nodes. This is the peer node endpoint. Once again, you configure your client. When you install chain code, you'd be interacting with this here. Peer node type and the AZ it's in, and then you can easily create them as well. So before we end the demo, I want to show the invitations page. So in this case, I got invited to join a network, supply chain network, and it shows up here. I'm not part of it yet. Once I get invited, I have permissions to, the network shows up in the list, and then I can call the get network API to get more details about it, or visualize it in the console. So when I do that, I can see a little bit more about it. In this case, there are already 3 members in this network. As you can see here, the owner is other account, and I can't click them. I can't get any more details about them because I don't own them yet. One thing that we might add, though, soon is that when creating a channel, you need to have some certificates. Right now, today, the public certificates, you would just pass them around, and whoever wanted to join would send you that, and then you'd create the channel configuration update by adding them. But most likely we'll be exposing a way to access those directly from here, because it's kind of not giving away secret. In fact, that's just the normal way of creating these channels. So now you see here, there's a couple of other organizations: Vidit Corp, Virtuoso Group, and Hokanen Inc. And then once again, here's the ordering service endpoint and the VPC endpoint. So if I wanted to join this network, I haven't joined it yet, and the invitation would expire at some point, and then I wouldn't be able to come back and do this. But while the invitation is live, I can then create a network and join it. Okay. So that's a quick run through of some of the functionality, and then the next thing that you would do is you would create the VPC endpoint, create a client machine, and then start interacting directly with those endpoints and create transactions, install chain code, and transact on the network. Okay, so a couple more slides. I want to really end with just a bit of information about the preview. So once again, the preview is live. You can sign up. In the last slide, there's some information on the different links. One of them is the preview sign up link, where to go. Fabric is available now in the preview. Ethereum's coming soon. Your preview is also is free, basically. And there's some terms and conditions on what it means when you get your invite after being added to the preview. Please read it, but we're not charging for preview usage at this time. Your resource limits: you can be part of one network, have 6 Hyperledger Fabric channels in that network, up to 5 members in a network, although you can only own up to 3. So if you want to create a test network where you own everything, you can get up to 3 members and then simulate multi-party transactions. Right now it's 1 peer per member. We're limiting it to the T3 small instance type and 30 gigs per peer. Right now the adding members portion, our voting API, is coming soon, and whoever creates the network will get to add more accounts if you want to send those invites that way. And then to delete a network, it's really the last person out. So if I create, say, a 3-member network I own, I just delete all 3 members, and the network will then terminate itself. And then keep in touch with the docs. We have the thing about known issues, new features coming out. During the preview, we'll be adding our support for Ethereum, voting API, and some other cool things as well. And then here's a page with all the resources, documentation, our web page, and then a link to the Hyperledger Fabric documentation. Because once again, at the core, it's, if you're running a Fabric network on managed blockchain, all those Fabric concepts are super important, and all those APIs are exposed and described a lot as well in the Fabric documentation. So once again, join our preview. We've had a lot of great feedback from our customers so far. Here are some of the customers that we've been working with in our preview period, and this kind of really just shows the way so many different industries want to adopt and start working with blockchain. I mean, you've got a lot of great companies here doing lots of interesting use cases across their respective industry verticals. And so we'd love to work with you as well. Sign up, please send us your feedback, and we're very excited for it. So anyway, I'll end with that. Thank you so much for taking the time to learn a little bit about our new service, Amazon Managed Blockchain, and I'll take some questions afterwards as well. So thank you so much. Take care.